We have L, O, V, and E, or love, are points on a circle. Each of these points is connected to each other by a line segment. How many line segments are there? So let us try to picture out it. So we have circle and there are 4 points lies on that circle. So problem is we're going to find the number of line segments if we try to connect these 2 points. But we need to consider this formula. So let n be the number of letters. So LOVE, count it individually, so we have 4. Then substitute given formula, so we have 4 times 4 minus 1 over 2. Then 4 minus 1 is 3, so we have 4 times 3 over 2. Then multiply it, we have 12 over 2. Then the quotient is 6. So meaning to say, if we have LOVE, our points on a circle, then we can create 6 line segments. Now let us do the actual. So if we try to connect LO, that is 1, LB, that is 2, LE is 3. We still have OV, 4, VE, 5, and we have EO or OE, 6. Which means this formula will satisfy the given problem. So meaning to say, if the number of letters increase, still you can apply this formula. Okay, so that is how we are able to solve the problem number 3. Let's move with number 4. Okay, here find the value of x. 3 times x minus 2 equals 5x minus 12. Let us have solution and reason. Okay, first is, of course, bring down the given. And we're going to multiply 3 to the term inside the parentheses. So we have 3x minus 6, bring down 5x minus 12 by distribution. Then we're so concerned with the value of x, we're going to transpose 3x to other side, become negative 3x, and negative 12 to other side, positive 12. So we have 12 minus 6 equals 5x minus 3x. So we can subtract 12 minus 6 and 5x minus 3. So we have now 6 equals 2x. So we're going to multiply whole equation by the inverse of 2. We have 1/2. Then distribute. Then we know 2 divided 2 is 1. So x equals to 3. If we want to check whether our answer is right, let us use the value of x, which is 3, and substitute it to the original equation. So we have 3 times 3 minus 2 equals 5 times 3 minus 12. So we know 3 minus 2 is 1. 1 times 3 is 3 on the left side. On the right side, 5 times 3 is 15 minus 12, which is also 3. So we need to say the value of x, which is 3, satisfied the given problem. Okay, let us have another example about this, finding the value of a known. So we have here 5 times 2y minus 3 equals 8 plus 5. Do the same process, bring down the given. Then multiply 5 to the term inside the parentheses. We have 10y minus 15 equals, bring down 8y plus 5 by distribution. Then we're going to transpose 8y to other side. It becomes negative 8y. Negative 15 to other side becomes positive 15. So we have now 10y minus 8y equals 5 plus 15. So 10y minus 8y is 2y. 5 plus 15 is 20. So again, we're going to remove 2 by simply get the inverse of 2, which is 1/2. Then distribute it. Then 2 divide itself, which is 1. So y equals to 10. Again, if we're going to find whether our answer is right or wrong, let us do the checking. Let us try to substitute 10 to all the y's in the given original equation. So 2 times 10 is 20, minus 3 is 17, then 17 times 5 is 85, equals 8 times 10 is 80 plus 5 is also 85, which means the value of y, which is 10, satisfies the given problem. Okay, let us move with the problem number 6. So how many intersections do we have when there are 18 lines to be intersected each other? Okay, so this time we're going to identify the number of intersections if we're going to draw number of lines. So let us put it in this way. If we have 2 lines, the number of intersection is 1. If we're going to draw another line, the number of intersections becomes 3. So, using this formula, let us try to validate, or let us try to check whether this formula will satisfy the given figure. Okay, so again, we have two lines. So 2 times 2 minus 1 over 2. 2 minus 1 is 1, 1 times 2 is 2. 2 divided 2 is 1, which means 1 intersection. Then if we're going to draw another line, so n becomes 3. So 3 times 3 minus 1 over 2. 3 minus 1 is 2 times 3 is 6. Divide 2 is 3, which means it will satisfy the given problem. In short, in our problem, we have 18 lines. So let n be the number of lines, which is 18. Use the formula 18 times 18 minus 1 over 2. Then simplify it, multiply it, then the quotient is 153. Therefore, if we have 18 lines, the number of intersections between that lines can be solved using n times n minus 1 over 2, which is 153 intersections. Problem number 8. Take a survey with 5 yes or no answers. How many different ways could you complete the survey? So, by the way, how many questions that you need to answer? There are 5. So, let us have this table. So, we have items, which is 5, 1, 2, 3, 4, 5, and each item you can answer it either yes or no. Okay, so it's so clear here. Let us have to express it in a diagram. Okay, in item 1, the possible answer is either yes or no. That is 2. On the second item, we can yes, no, yes, no. So becomes 4. On the third item, yes, no, yes, no, yes, no, yes, no, yes, no. That is 8. Meaning to say, if this would be the pattern, we can apply this formula. Capital M to the power of n. So let n be the number of items and small capital M be the number of options. So in our problem, 5 is the number of items, yes or no is the number of options. So let us try to identify that 5 is the number of items, that capital M is the number of options. We're going to solve it, the formula. We're going to use the formula to solve the number of different ways. So 2 to the power of 5 and 2 to the power of 5 gives a product of 32. Final answer. So meaning to say, if the problem needs to know the number of different ways that you could complete the survey, you're going to use this formula even in a multiple choice. Example, if we have 3 items and each item has 4 options, so therefore you're going to solve it as 4 to the power of 3. 4 times 4 times 4 is 64. Okay, so that is how the m to the power of n works.